So this is my video continuing on section 3.1. We learned about quadratic functions, but we are now trying to see how we can find the maximum and minimum of quadratic functions. Now, as I mentioned before, quadratic functions can either look like a ball, in which case you have maximum, like a dome, in which case you have maximum, or it may look like a ball, in which case you have minimum. So like for example, a cost can be a minimum cost, maximum profit, or the height of a football can be a maximum. So it is important in optimization, in business, and physics actually to find the coordinates of these maximum and minimum points. And to find them is very easy. What we do is there's a formula for that right away. You can actually even pick it up from the once you get it in the standard form. But uh, an easy formula is actually the x coordinate of the maximum is given by negative b over 2a, and that is if you think of the vertex or the vertex as hk, x coordinate h is given by negative b over 2a, and k can be obtained by taking this h and plugging them in the equation. Of course, we assume the equation to be our ax squared plus bx plus c. So just plugging in for b and a, we can find h, the x coordinate, and then once you get that, we can plug that value h for x, and then the y value that we get will be the k. So let's do a simple example. Um, so we have, so suppose find the minimum value of x squared plus 2x plus 1. Okay, so quadratic. And also it is a bowl because the leading coefficient is positive. It's like that. So we need to now find the coordinates of this minimum point. So you have h is equal to, we know that h is equal to negative b over 2a. Okay, so if h is equal to negative b over 2a, then what is negative b? Negative b is negative 2 over, that's negative 2. That's because b is this, right? And over 2a, 2 times the coefficient of 1. So negative 2 over negative over 2, which is negative 1. So right away, this is a is 1, b is 2. So b you put 2, and a is 1, you put a equals 1. So that goes here, this goes here, and you get negative 1. If you want to find the k, you just take that negative 1 and plug it up here, and then you get negative 1 squared plus 2 times negative 1 plus 1, and when you simplify that, you get 1 minus 2 minus plus 1, which is 0. So this is the y coordinate of the minimum, and this is the x coordinate. So the minimum happens at negative 1 and 0, like this, and that's how we find. If you want to do a word problem, so Amy has a hot dog stand, and the cost, when you make x hot dogs, the cost is given by this function. Okay, so you want to minimize, so it's a quadratic, you want to minimize. These problems are very easy. So again, you want to minimize, you put h equals negative b over 2a. So what is b then? B would be negative 20. So it's negative of, the b is negative 20. The whole b is negative 20. So negative 20 over 2 times, what is a? The coefficient of x squared, which is 1. So negative or negative 20 is positive 20 divided by 2, which will give you positive 10. And now you take that 10 and then plug it up here. You get 10 squared minus 20 times 10 plus 500. Okay, and then you get what? 10 squared is 100 times 20 times 10 is 200 plus 500, which is 600 minus 200, which is 400. So that is the k, which is actually the y coordinate. So that means that is the minimum profit. So this is the minimum cost. And now you're gonna ask, at what price do we get to sell? So if you, so x is actually the units, right? So when you sell 10 units, you actually get the minimum cost, which is actually 400. So he needs to spend 10 hot dogs to minimize the cost, and the minimum cost is 400. It's a kind of a weird problem, right? Okay, because I just put up these numbers, right? But you know what you have to do, right? You take the function, right? Identify what a, b, and then by plugging in this formula, you get h and k. That's it for this video. Thank you for watching.